This topology has already been given to you in a previous video, and in this tutorial we start by adding the application layer protocols. We will configure them one by one. Let's first start with DNS. As you know, DNS maps names to IP addresses. It can be a website, web server, email server, FTP server, any name to an IP address. So I will go and change this network C. I'll call it servers LAN. We will use it to put all servers in it, and all servers will have some kind of fixed IP addresses static. So let me start with DNS. And why is DNS? We can start with the HTTP. HTTP is a web server. I'll go here. I'll take a web server from here. I'll put it here. I'll connect it to the network. So it's now connected, but definitely it needs to be configured with IP addresses. So let's call it, just give it a name, www.final.com. This is just a name. And let me pick one of the available IP addresses in this network. So I think 112.30.0.165 is available. And this is going to be the web address of, or the IP address of this web server. The name is not given to the server itself. The name is configured on the DNS server. The first thing when you add a server, go ahead and give it an IP address. Again, it's going to be static. So 112.30.0.165, 255, 255, 255, 240, and the default gateway is 161. That's it. Now it's configured. I will go and configure HTTP service. Honestly, in Blackboard or in Packet Tracer, nothing much to be done on a HTTP service, because both protocols, HTTP and HTTPS, these are two different protocols. HTTP works on port number 80, HTTPS works on port number 443, are ready. What I usually do in such a tutorial, I'll go and just add one statement on the website homepage, which is index.html. I'm just adding something very simple. So I'll come here and say, for example, SMPT 355 testing. That's it. So I click on save. Yes. So our web server is ready and is reachable, by the way, but you still cannot reach it by name, because no one knows its name. Its name has never been added to any DNS server. So if I go, for example, to this PC here and try to visit the website by its name, it's not going to work, because one, our client has no DNS server. Two, because the server has never been given to any DNS. So I'll just go here on the client and try to go to the web server first by name, which is gonna fail definitely. I'll type www.final.com. It's gonna fail definitely because our client has no DNS configured, and actually there is no DNS in the entire topology. طيب. Next, I'll go by name, by IP address 112.3.165. As you see, it works. So I can go to the web server by its IP address, but not by its name. See, this is the text I added here. So next step is to add a DNS server. A DNS server is a database that maps names to IP addresses. Again, a database that maps names to IP addresses. So I'll go here now and I will add a server to the topology. I'll call it DNS. And let us give it an address like 112.30.166. Again, first thing to configure is to go to desktop IP address. This is a common mistake by students in this course. 166.255, 255, 255, 240. And here we go to the default gateway, which is 112.30.0.161. Configured. Now I need to go and configure the service. Which service we are looking for? DNS. Click on DNS. Make sure the service is on. Service is on. It's like when you have a real server. Usually you start the service, there will be like a 24/7 program listening to requests on the DNS global port number. So service is on. So now let us add the first server name, which is final.com. Make sure you add www.final.com and its IP address 112.168.0.165. Double check before you click add. Now our DNS server knows the IP address of final.com, and by the way, it doesn't know any other IP address. So I'll close this and look now, we still have one missing step. I need to connect the server to the network. So let's go here and connect it to the switch of the server's LAN. Good. One more thing is needed. I need to go to this client and tell the client who is the DNS server, 112.168.0.166. So now, on this computer, on this client, whenever you type a name, it will go and ask this DNS server about the IP address of this name. Let us close, go to web browser, and try to go by name, and I believe it should work. www.final.com. It worked here. We see the web server has been reached by its name with the help of the DNS server. I'll show you the second one with simulation. I'll go to this PC also. I'll configure it with DNS server 112.30.166. And now I'll switch to simulation. I'll edit filters. I need DNS and HTTP. Okay, and let me make sure it's HTTP, not HTTPS. So now I'll show you what happens when the client tries to go to a website. It will first try to go to the DNS server, ask it about the name, and then the DNS server sends the IP address of the server, and then you can go to the web server. So now I'll go to the same website from the second client. Here, I am here on this client, www.final.com, and I want you to see what happens. The very first thing, this device issues a DNS request to the server. Look at it now. It's a DNS. Let me just make sure the type. Yes, now you see the type of the. See, it's a DNS request. I can stop it and show you where it's going, but I want you to watch all the round trip. It will go to 166 with one question. There will be a question in this field packet. It was received. I'll show you the question. I'll stop it now. I'll open this one. I'll open it. I'll show you the question that has been sent by the client. The question is, here is the question. What is the IP address of this website? This is the question. In a minute, I'll show you the reply of the server, which is going to be the IP address of the client. So this is the question. Let us continue now. Okay, the reply is coming. I'll open the reply and show you what is the IP address. I'll open it now. I stopped it. I'll go here, double click, and go to the outbound, inbound, doesn't make a difference. And somewhere you will find some, it depends. Here is the source, destination. I don't see the answer. Let us see the answer. And it's going to be somewhere in the bottom. Here is the answer. So you see DNS answer is going to be in the bottom. And this is the format. In this field, the client will find the IP address of the destination server. So let me just make it quick. See now, once the DNS is received, you will see HTTP request goes to the server. Maybe it's going to time out. No, it didn't. So now HTTP request will go to the server. Normal HTTP request. I'll make it faster so we see what happens. Of course, once the HTTP request is sent and received, the page appears here because the server will reply with the HTML page of index.html, which is the home page of the web server. And now we see the page appearing. Good. So done with DNS and web. I'll go back to real time now. I'll add another web server just to test it twice and make sure everything is working. Clear. I'll just switch back to real time. I'll add another web server, just any name. Okay, here. And I'll call it www.demo.net. And let us give it IP address 112.30.0.167. First step is go and desktop, give it a name. IP address 112.30.0.167. 255.255.240, the subnet mask of the LAN, and the default gateway is 161. Good. Now I go to services, HTTP, both are on. Again, I'll call it demo site on index, demo site. Just added 2 words to make sure we are seeing it. I'll go now to connected to the switch of the server's LAN. Next step, I need to go to DNS and tell DNS about the new name. The new name is www.demo.net and the IP address is 112.30.0.167. Add. So our DNS server now knows 2 IP addresses. Let's try to go to the same website from here using real-time mode, www.demo.net. It worked fine, and here we see the demo site. Now let's go to another application layer protocol, which is email. Email is a bit unique protocol. It uses actually 2 protocols. One for sending emails, SMTP, which uses port number 25 and the TCP layer. And for receiving emails, it uses a POP3 protocol, which uses port number 110 on the TCP layer. So we need to configure 2 things actually for an email server. So think about it. It's like when you go and register on Gmail or any other public email server, you need to put your credentials there, and we will do that. So I'll take an email server here, and we will also give it a name. This is our email server. I'll call it funmail.com, and let me give it an IP address 112.30.0.168. So now let us go ahead. First step, as usual, go ahead and configure the IP addresses 112.30.168 and subnet mask of the LAN and default gateway of the LAN 161. That's it. Now I'll go to services. I need to check email. Look for email here. So the service is on, but if it was off, you must make it what? On. For both, you see, SMTP for sending and POP for receiving. Now, one important point here in Packet Tracer. You need to set the name of the email server here, domain name. Make sure you don't add www. The name is funmail.com. Once you do this, make sure you click on set. If you click on set, you see now the button is disabled because the name has been set. So now we did IP address. We made sure SMTP and POP are all open. And now I added and configured the funmail.com domain name and clicked on set. So now let's try to add users. I'll add Steve here, 1, 2, 3, 4, 5, 6. Click on add. I'll add Ali and 1, 2, 3, 4, 5, 6. Add. And I'll add Mike also 1, 2, 3, 4, 5, 6. Add. So now I did configure the IP address and SMTP and POP are on. I also configured the funmail domain name and I added 3 accounts. So we still need to do some work on the client side. So I'll go to this PC, and from now on, I'll call it Steve. So this is our Steve PC. I need to configure the email client. The email client, guys, is similar to the Outlook email you configure on your PCs. So maybe you need to configure some username, password, and save your credentials there. So on the client side, I go to email. So this is your first name. Let us make it Steve Jobs. And email address, it should be the same email you configured on the FunMail server. So it's going to be steve@funmail.com. So incoming and outgoing email servers is for us here in this topology, they are the same. So I'll make it funmail.com and funmail.com. Remember, I'm using the name now of the server, not its IP address. If I'm using the name, I still need to go somewhere to a DNS server and put this name and IP address per there. So now what was the name? The name was Steve on the server, the password 123456, and save. So I configure Steve. Let me go and configure here. I will call this one Ali. Okay, Ali. I will go here. So I will need to configure desktop email. The username is Ali Hassan and email address is ali@funmail.com. Incoming and outgoing are the same, funmail.com, and Ali was the username and 123456 was the password. I click on save. So now I configure two clients, one on Ali here and one on Steve here. I still have a third one, I'll use it. Let me try to send an email from Ali to Steve. Client, here you use compose. Of course, compose. Oh, we need to do one thing. I need to go to the DNS server and DNS here and add the new name. Remember, do not put www here. This is not a web server. FunMail, and the address is 11.12.30.168. And now I add it. So now my DNS knows the IP address of FunMail. Otherwise, it will fail because the name is not going to be there. One more step. I don't think I configured Ali with a DNS server. So Ali is not aware of the DNS server. So let me go ahead and just give it the DNS server IP addresses. Close everything now. So I'll go to Ali and try to compose a message to Steve. So here I say steve@funmail.com, testing from Ali. Okay, reply ASAP, and click on send. Let us see success. I need to see send success. If something is wrong, it will either take long time. Connection timed out. Okay, did we configure something wrong? I'll try again. steve@funmail.com with subject testing, mail server, resolving name. The name has been resolved, by the way. So let me server has been found in the DNS, but there is something wrong. So let me go here to Steve and see if Steve is, let me go to the server. Wow, huge mistake. The server is not connected. I did not connect the server to the switch. That's it. Alas, that's it. So quickly here, simulation real time. This is a trick in Packet Tracer to the network will connect quickly. Devices will know each other faster. Now I think it's all done here. I don't see a reason why. Okay, compose, and hopefully Steve replies at funmail.com. Okay, test, reply ASAP, send. As you see here, send success. So now if I close this and go to Steve, the Steve now will retrieve the email from the server using which protocol? POP3. Click on receive. We see the message here from Ali, test, reply ASAP. I can reply, but before I reply, I want to show you how things work with email. So I'll go to simulation. I'll go to edit filters. I need DNS. I don't need HTTP now. I need SMTP, and here is SMTP, and I need POP3 here. So I go to IPv4. So DNS, I'll show you how the name is received and all these things. Let us do the simulation now. I will go to Steve, try to reply. So reply, if Steve tries to reply, Steve device needs to know the IP address of funmail.com. Once the DNS reply comes, it will send the email to Ali using SMTP. When Ali goes and try to receive the email, he will open it using POP3. Let us click on send, received here. Let us say, well done. Send, good, DNS. So Steve is asking the DNS, what's the IP address of funmail.com? The DNS replies with the email of funmail.com. Now SMTP, see, SMTP sends the email to the server. The email is sent to the server, not to the client. That's it. And it receives acknowledgement, send success. Good, excellent. Now I'll go to Ali on the other side here. It might take, the device is going to become slow because so many things here. So let me clear the buffer, but I'll go to Ali and show you how retrieving an email will also work. Clear event list here. I will go to Ali. I will go to email and click on receive. Again, look at the things here. DNS, again, Ali asked the server, what's the IP address of funmail? If you are wondering why the device has been asking multiple times, it sometimes happens that the cache, DNS cache in the device times out, and so it goes and requests the name again. And POP, as you see, POP is used to fetch emails or bring emails from the server. By the way, this is not the latest email technology. There are other protocols like IMAP, which is a bit different. But this is one of them we teach using Packet Tracer. So if I open Ali here, it's available, the email is available, and everything is fine. Here we received, okay, let me just switch back to real time and clear the buffer. Okay, the device becomes slower when you do this. Clear events list, real time, and here I'm opening Ali, and this is the receive, and I see this email received, well done. Next, now we will configure devices with dynamic IP addresses. IPv4 is very limited, and usually devices or hosts in a lab or business topology are given dynamic IP addresses. You are getting also dynamic IP addresses when you go to your homes, when you go to university. From the router services, there will be a pool of IP addresses dedicated for dynamic users like students, faculty members, or other people. So what happens here? We will dedicate one DHCP server for 2 LANs and show you how the devices can be given the IP addresses. I will go to network D now, and I'll add a DHCP server. DHCP server is here. I'll give it an address first, DHCP, and this is going to be limited to network D pool, okay? Because you still can configure DHCP servers to serve more than one LAN, but you might need to configure the ports of the router, and this has already been explained in another video. So DHCP, let me see a free IP address here, 112.1.30.0. Okay, I think 70 is fine. So 70 will be our DHCP server. Before we continue, you need to ask yourself which addresses of my LAN I need to make them dynamically given to hosts. Remember, switches, routers, servers are usually given IP addresses in a static format. They do not change. Routers need to be accessed from all over the planet. However, devices like your home devices, your phones, and if it's not a server, usually the IP address given to it will be dynamic by a dedicated DHCP server. So now let me say, in this LAN, I will give addresses from 80 to 100 to DHCP clients. يعني addresses from 112.30.080 to addresses from 112.30.0.100 will be available to be used by any dynamic client. This is one. I will go here first. I'll configure the IP address of the device 112.30.0.70 and 255.192. 1112 is okay, 30.0.65 is the LAN. Okay, so now this is done. Next is, I can configure it with DNS, but it's not a big deal. No one is going to ask a server about DNS if you're wondering why I skip this usually. Tamam. So DNS is actually 166 here. Good. So we configured the IP address. Now we need to configure the service, and you need to pay attention because there are so many details here. I go to service DHCP. We are not talking about DHCP6, DHCP4. The service is on. In this tutorial, I'll make two DHCP servers, and both of them have only one pool. The DHCP server usually give not only the IP address to the device, it gives it the right subnet mask, the right default gateway, the right even DNS server. And if there are other services like TFTP server or something, it can also be used. It can be very helpful in automatic configuration of IP addresses. So now let us see the details. I will be using this from 80 to 100 for network D. So what's the default gateway of network D? 1112.30.0.65. What's the DNS server of network D? 1112.30.0.166. What is the starting IP address to be used for dynamic IP addresses? Start from 80. What's the subnet mask? This is the right subnet mask. So if we start from 80, how many devices you need to give? Don't use 512 because actually we don't have 512. So we need only 20. As you see here, I said we will use addresses from 80 to 100. Now don't click on add. Click on save. Don't click on add, click on save. Make sure the service is on. And the service is on means it will be replying to request on any DHCP and connect the server. So our DHCP, by the way, is configured now. The service is on. Right default gateway, right DNS server, starting address 80 for 20 addresses, and I clicked on save, not add. If you have multiple pools, you need to click add, but in this example, no need. So now let me close this. Let me show you what happens now. I will go to simulation. Let's first do it without simulation. I'll go to real time. I'll show you Steve. Steve now has the configuration of Steve is using static IP address. I'll show you what happened when I click on DHCP, and it takes like, oppa, good, excellent. So Steve received an IP address with a subnet mask and default gateway and also what? DNS. From where? From the DHCP server. Look at them, all are correct. Exactly the same way we configured in the DHCP server. So now Steve is no longer going to be this address. Now Steve is a dynamic IP address, and it might change. Let's go to this PC here, and I need now to switch to simulation. I need to show none. I will go and only show DHCP and show you what happens when the PC tries to obtain an IP address. This step must have been explained to you before, but it takes 4 steps actually. All of them are broadcasts. The client will send a broadcast, everyone ignores it, the server replies suggesting an available IP address. The client says, okay, I'm going to take it. The server confirms this. So 4 times, and all of them are broadcast. If you are wondering why it's broadcast, because the IP address will not be confirmed to the client until the 4th step. So let us now go to this device and click on DHCP and see what happens. Broadcast, and see the broadcast does not go outside the network. They are communicating 4 times, by the way. If you look at it, all of them are broadcast. Done. I will open this and show you what's inside it. Please don't. Okay. I will open this and show you what's inside it. Please don't. Okay. Let us see. What you will find inside it, the IP addresses that has been given to the list. Here, I'll open it. Here, look at it. This is the source, which is the DHCP. This is a broadcast. If you look at destination port 68, this is the port of DHCP server, the globally configured or selected port for DHCP server, and 66 and 67 are using these IP addresses, port numbers. I want you now to see your client address. This address is sent by the DNS server to the client, is telling it this is your client address and this is a confirmation. So now, if I go to the client, I'll switch back to real time. If I go to the client here, it received address 81. As you see, they are in the same order. Okay, so I will switch back to static. Now the device loses its IP address now. And I will show you again. I'll make it a bit slower so you see what happens when we try to obtain DHCP. That's it. Broadcast to everyone. And I want you to pay attention that broadcast never go outside the LAN. The router blocks them. And that's what you need to know if you want to configure DHCP servers outside the LAN. Broadcast reply 4 times between the client and the server. Finally, the server gives the client in the 4th step. The client gets its IP address and starts using it. This is not a DHCP course. It's how to configure DHCP on Packet Tracer. So now it's done. I click on simulation mode and it's 81. Let's do the same thing for this LAN also. I'll bring a DHCP server. Let's find a free IP address in this one, because you know servers addresses must be static. And let me say DHCP for this LAN. And this starts at 0 to 64. So we'll make it from 20 to 50 will be dynamic. And let us find 1112.30.0. I believe 5 is free here. So 5 is free. So let's first go and configure the static IP address of the server. The subnet mask is 192. And the default gateway is 1. DNS server is 1112.30.166. Again, this is just additional step. Now I'll go to services, DHCP, it's off. Again, now we are configuring network B. What's the default gateway? 1112.30.01. And DNS server 1112.30.166. Starting address, I believe I said, where is it? My DHCP here. Okay, what is the DHCP? Oh, 20 to 50 here. So I'll go and configure it here. 20 starts at 20. So we need 30 addresses. Again, click on save and make sure you click on on. If you don't click on no one is going to reply to this. Yalla, let's go here. I will go to Ali, which has been used using static. I'll make it dynamic. Excellent. It's got the first one. I'll go to the second one here, desktop, and it will get 21 maybe. Yes, excellent. So now, again, Ali is also using what? Ali is using a dynamic IP address. Tamam. So this is DHCP. The only difference if you have DHCP for multiple LANs is just you just need to configure the router port with IP helper address. Let me try to do it here. I will configure also network A to use DHCP. I did not prepare for these settings, so let us say say in this LAN DHCP will be addresses from 140 to 150. Okay, from 140 to 150 will be used for DHCP. However, now I need to configure this DHCP server to serve both LANs. As you know, the router blocks broadcasts, so let us see what happens. I'll go here, DHCP. I will now add another pool. Let us call it Net A, Network A. The default gateway of Network A is 112.130.129. DNS server is the same. And the starting IP address will be 140, I think I said. The subnet mask will be 224 and only for 10 BCs. Let us review the things here. I'm talking about a pool for Network A. The pool has a name now. This is Network A, default gateway. 224 is right. Starting address is 140. And this is gonna be okay. Network, hopefully add. This is server pool net A. That's it. And the service is on. However, if I try to go to this one and configure it with DHCP, most probably is going to fail because the broadcast, DHCP broadcast will be blocked. You see, it received an address that starts with 169. 169 is not an internet address. They call it a BEBA. And this means fail. You know, when you see this one, when you see your computers or phones, they tell you connected but no internet. So this is an emergency but no internet. It's only link local website. I will show you what happens actually in real life here. I'll go to this one and I will show you what happens when I try to configure the DHCP. See, the DHCP broadcast cannot reach this server. The DHCP broadcast cannot reach this server because they are blocked here. All broadcasts are blocked. So our step here is to go and configure the broadcast to be allowed to go to the server. So I will close this now. I will go back to real time. I will go to which port? To this port. I will go to this port. This port should be configured, not the router itself, the port itself. Okay, so I'll go to port GI000. I will configure it, enable conf t interface GI000. And the command should be very simple. IP helper address. IP helper address. And the helper address is the address of the DHCP server that needs to be used, which is this one. I'm using it. So now I go back here and use the address, which is 112.30.05. IP helper address. It worked now, helper address dash between them. So now let us go back and see what happens. It's one simple command I did. Let us see this one, static, and now DHCP. And let us click on run. Now, is it going to be blocked? It did. It worked now. Yes, received by the DHCP server. Replied. Is it going to be allowed now? It's a broadcast, remember. But they know where to send it. The reply will not be a broadcast now because they know it's a different network. Excellent. So we'll see this 4 times. Maybe it times out. Maybe it's going to time out. It depends. So I'll keep it with a normal speed. Okay, good. So far, inside the LAN, everything is broadcast. Okay, good. Now unicast this one. Good. reply. So this is step number 4. This should be the last step, in which the DHCP server confirms the location or of the IP address to the client. Once it's received there, we'll switch to real-time mode and see what happens. I'll switch to real-time mode here and see what happens here. Excellent. Did we get it? Right. Excellent. So I'll go now to this one here and I'll do DHCP. This is going to be very much faster because it's not going to need simulation slowness. As you see here, one simple command allowed me to have the DHCP server in a different LAN. You just need to configure the port where the LAN is connected to allow the broadcast to go to the destination DHCP address. And here I created not one pool now. If I go there, you see 2 pools, and that's it. Network A and server pool, which is the local LAN. It's time now to add an IPv6 router with 2 IPv6 LANs to the topology. I'll pick this router 4331. It's very simple to configure. Let me go and add ports to it. I think I know what ports I need. Let me zoom in here. Okay, this is 4311. I will add serial. Okay, here is 2 serial. I just need to switch it off. Here 2 serial ports, and I have what I have here Ethernet ports. Good. So I'll just add 2 serials to it, and already LANs are there. So let me close this now. So let me create 2 LANs here. I'll use switch 2960. It's honestly very simple to configure it for IPv6. 2960. I'll connect them to the, okay, here, GI00 is the left one, and I will connect it also to this one, GI001. I'll connect it with a serial port to R2. So now what we need to do is to use this network and subnet it between the 2 LANs. Let's give them name. Okay, net E, and this one net F. So when we talk about them, the names are clear. This is the network. I need to configure it to like /64 to both of them. This is 48. If I configure it to 64, it will be a huge number, 2 raised to the power 16. And it's going to be, I think, easy. Let me just see what I can do here. I can configure it because if it's 64, I will select the first one here. Okay, 0 for the left one here for net E, and I will select network 1 for the other side, and this one is 1. So here, because we have borrowed 16 bits, so these are the 2 networks that to be used for net A and net. Let's first configure the router. First, most routers do not accept IPv6 directly, so we need to configure this router specifically. Let us see how we do this router. conft. You need to apply this command and make sure it works. IPv6 unicast routing, that's it. If it's accepted, then the router is now running IPv6 and IPv4. So let's configure IP addresses. I go to GI00, which is for net E, this one here. Okay, I'll go for this one and try to configure the IP address. Any command you learned using IPv4, just use IPv6 and apply it. IPv6, oh, first I need to go to the port interface GI000, then IPv6 address, and now I need to copy paste the address, this one. I'll give it the first address in this network, so I'll go here and give it the first address, which is 1/64. This is the first subnet. No shut. Excellent, was accepted. I will go now to the other port interface. Let me see the name this port for network F. It's GI001. I will go to interface GI001 and let me repeat the same command, but now the network is gonna be 1. No shut. Excellent. And I don't see the ports on. Okay, I will see this. Oh, I made a mistake. I did not go to GI001. So now I need to repeat both of them, actually, because I am in GI000. So this is my network here. Now I need to go GI001. Yes, now I need to give it the address of the other port, and then I give no shut here. And I'm getting overlap. So let me just go to there and make sure. If I need to know the IP configurations here, I just need to go out, show IPv6 interface brief. So let me see. I'm still using okay, one address. Oh, still I did not cancel this. So let's see how to cancel it. Enable conft no interface GI000, no IPv6 address, and let me paste. What's the address here is 11. So this is going to be 1 here, 1:1/64. Okay, and then repeat the command IPv6 01. Here it should be. This is the first subnet we selected. No shut, make sure it's working fine. Now I go to interface GI001 and IPv6 address 11 should be here, and no shut. I believe it worked now. Yes. If you want to double check the addresses and show IPv6 interface brief, yes, both are fine. Now let's go to the switches. This switch is 2960. Each switch has its own way of configuring it for IPv6. Enable conft, and this command is not yani common command. SDM ? Prefer ? Dual, both, and default. So the command is SDM prefer dual IPv4 and IPv6 default. I believe the command itself is self-explanatory. Okay, what they tell you now, you need to save and reboot or reload. Yes, save and reload. Okay, after it reloads, the IPv6 will be activated. I'll go to the other switch, CLI, quickly here, enable, Ctrl+Shift+6, enable, conft, SDM, prefer, dual, default. Okay, and reload, and yes, and in. That's it. So now if I go to this one, I will find it ready to use IPv6. Let's make sure, Here, Ctrl+Shift+6, enable, conft, I'll configure interface VLAN. Interface VLAN 1, IPv6 address. I'll just give it the second address in the LAN, which is 02 here. Will be 2/64, no shut, and it worked. If you want to check if it works or not, try to ping the default gateway. Ping. The default gateway is 1, so here you need to ping 1. Success rate is 100%. I'll go to the second switch. It's ready now. enable conft interface VLAN 1 and IPv6 address, paste, and this network will be 1::2/64, no shut. Again, I can ping the default gateway in this LAN, ping, paste, default gateway is 1, and success rate is 100%. So I configured IPv6 on the router. I also configured it on the switches. Let me just bring one PC from each LAN here and give them the address, the next address, just static addresses. Okay, this is desktop IP, IPv6 here. I will use it here. This will be 0. I used 1 and 2. This will be 3 and 64. That's it. And let me ping also the default gateway from here. Ping. Okay. Right click, paste. Will be 0, 1. Okay, excellent. It's working. I will go to the second PC here. Also configure it with its own address. Desktop. Oh, okay, first address here, IPv6. Okay, this is gonna be 113 and the subnet mask is 64. That's it. And one final time to ping the default gateway, and this is gonna be 1::1. Hopefully it works. So I did subnet one IPv6 network. Still the connection is gonna time out. Now it's gonna work. Tamam. So I did configure it. I did subnet it into 2 subnets. You have thousands of subnets if you want. I give the first address to the default gateway, second address to the switch, third address to the PC. I can also go and check the routing table of the new router, the IPv6 router. Show IPv6 route. So you get the IPv6 route here. So you have these networks and they are configured fine. Let us configure also the serials 100 and 021. Let me configure them. I will go here and conft interface. Again, I forgot what's that. Serial 010 and serial 010. Serial 010 IPv6. I'll use a new network, IPv6 address, and it's gonna be, I used network 0 and 1. I'll use network 2. I don't care about availability now. Network 2. I'll use this one, 64. No shut. I will also need to go to this router and configure it to allow IPv6 first, because I'm not sure I did. And conft enable conft IPv6 unicast routing. It accepted that. Now I need to configure this IPv6 port here, serial 021, and I give it the second IP address in the new LAN, and this is gonna be interface serial 021 IPv6 address. I believe I used the network that starts with 2. I gave the first address to the other port, and this is gonna be the second address. No shut. Hopefully the link is up now, and as you see, the link is up.